Okay, so our other video in forces is all about free body diagrams. And so what is really important to remember for this is that forces are known as vectors. And what that means is that they have a size, so a magnitude, a value, a quantity, all right? But they have a direction. So for example, we would say that weight acts down, it acts towards the earth. Friction opposes the motion, so it's acting in the opposite direction. So when something has, as well as having a size or magnitude and a direction, they're also known as a vector. And what that means is when I'm drawing these, I can represent them with arrows because arrows can help to show the direction. So there's a few little things that we need to watch out for when drawing a free body diagram. Okay, we need to be showing the arrows. Okay, we need to be using straight lines. We need to be drawing them from the center. The length should be in a scale representing the size. Okay, so if something's bigger, it should have a longer arrow. And they also need to make sure they're pointing in the direction that the force is acting. So I'm just going to take somebody stood on the ground. So this would be like a force diagram showing the actual object. We don't care about that in physics. We just make life really easy for ourselves. So we use either a little square or we can use a little circle. Okay, and what I'm going to do here is I'm going to show the person standing on the earth by this box, and I'm going to draw my two arrows. I'm just going to use pink for this one. And again, I'm going to label these. So the first one would be our normal, okay, or known as our reaction. And the one that's pulling us down is the weight. So I draw them from the center of the object. I just use my nice, like straight lines. The normal should equal the weight in this case. So I've drawn them to look like they're the same size. And then we just draw it from the center there. So I don't need to add anything else from it. So the straight lines, I've used my ruler. Okay, I've done them from the center. They've got the same length and they're pointing in the direction. So weight's acting down, normal's acting up. If I look at another example, let's say this is a car, okay, and I'm going to again be looking at all the forces on the car. We don't actually always draw all the forces here, but I'm going to say the person is, or the car is accelerating to the right. So I'm going to say that they've got a really large arrow to the right, so let's call that thrust. And they've got some drag force slowing them down. So let's call that drag, okay? And I've got then the normal force, and I've got the weight. So again, the normal, remember you can also call it the reaction, and I have weight slowing them down. So again, I've got straight lines, they're from the center. I've used the length to equal the size, so I can see they're accelerating because I've got more thrust, and they're pointing in the direction where they're acting. So normal's acting up, weight's acting down, drag's acting backwards to slow the car, and the thrust was making them go forwards. So that one was acting forwards or to the right in this case. Now, there are some other different free body diagrams as well. So just a few others to have a little go at practicing. So have a little pause, see if you can draw them yourself. So I've got a mass and a spring. So the mass is pulling down on the spring. I've got a ball rolling down a ramp, and I've got a plane taking off. So again, have a think how you could draw these ones. Right. So let's have a look if you were correct. So if we have a mass weight system, again, I'm just going to use a circle, and the mass and the weight are at the bottom. So we have, therefore, tension in the spring. Now that tension is going to be acting up. It's trying to pull the mass backwards. Okay, so I've got my tension acting up and then pulling it down. Okay, and because at this point it's balanced at the bottom, these two should be the same size. I'm going to have my weight. Okay, so I have tension and weight there. Now the next one for the ball on the ramp, again, I'm just going to draw my circle in, and it's really important to remember that our normal force is always perpendicular to the surface. So my normal should be perpendicular. Okay, now the weight is always going to be acting down. So I'm going to have weight. And then I'm going to have some friction, some drag force. Okay, I'm going to call this friction. And because this is rolling down the slope, remember friction is opposing its motion, so it's going to act in the opposite direction. It's going to act to oppose its motion, so going up the slope. Okay, now the next one is a plane taking off. So again, if I have a plane taking off, the force that is going to be bigger at this moment is got to be lift Also, you could have called it up thrust. Again, I'm just going to have some weight. Still trying to pull that plane down. We still have some drag force. And we also are going to have, though, a lot more thrust because they are accelerating to take off. So lift and up thrust and thrust need to be bigger than the drag force and the weight there. And I think, yep, that was the last part here. If you have any other forces, though, that you want me to have a go at drawing, please let me know.